Welcome everybody to Algebra 1, Section 2.4, variables on both sides. Let's start with 4 steps that we can use to solve these. So step 1 would be to distribute, and that's only if necessary. You will not always need to distribute, but you will sometimes need to. Step 2 is also only if necessary, and that is to combine like terms like we did in our Section 3 multi-step equations, where you combine like terms on one side of the equal sign. I'm going to put if necessary. Step 3 is to move variables to one side of the equation. So move variables to one side. And last but not least, step 4 is to, as it says, solve. But essentially that's using our two-step equation solving methods where we use SADMAP. I'm doing the subtraction addition first and then the multiplication division. So let's dive into example 1. On example 1 here, we have 5y on the left, 3y on the right, and numbers on each side as well. Our goal is to get y equal to some number, or some number equal to y, aka all the variables on one side, all the numbers on the opposite side. Now in order to achieve that, we either need to move this 5y from left to right, or the 3y from right to left. Now you could technically move the numbers first, either way. I just typically prefer moving the variables first. And so we have two options to do that. Once again, 5y from left to right, or 3y from right to left. If I were to perhaps move the 5y from left to right, which is actually I'm going to erase here in just a moment, just so you guys know, I'll get zeros, so I'll get negative 8 equals negative 2y plus 12, and that works just fine. I could also subtract 3y from both sides and get 2y minus 8 equals 12. Now I prefer this one, so I'd encourage you to write this down. And the reason I prefer this one is because now my variable is positive. And I like working with positive numbers more than I like working with negative numbers. So given that I have the choice here of whether to make my variable positive or negative, I'm going to choose to keep it positive. And a good rule of thumb to follow if you want to do the same is to move your smaller variable. So between 5 and 3, 3 is smaller, so I move that one. And that's keeping my variable positive. Now that I have my variables all on one side, I need to get my numbers to the opposite side. Once again, keeping with this theme that we want to get our variables on one side, numbers on the other. And so I add 8 to both sides here, and I get 2y equals 20. And now I divide by 2 once I get all my variables and numbers on opposite sides, and I get y equals 10 as my answer. And if you were to plug in 10 as your to both y's, you would end up getting the 42 equals 42, which is true. Number 2 here, as once again I have variables and numbers on each side, I'm going to want to move my variables together on the same side, either both on the left or both on the right. And so personally, between negative 6 and negative 8, I'm like, oh, negative 8 is smaller. So I'm going to add 8x to both sides. And we get 2x, there is my positive variable like I talked about, plus 14 equals 12. Then if I subtract 14 from both sides and move my numbers away from my variables now, I get my variables on the left, I get my regular numbers on the right, and I go ahead and divide by 2, and x equals negative 1. Now I want to mention, if you had happened to move your 6x from left to right, you'd have to move your 12 from right to left. So that way it's on the numbers are on the opposite side of the variables, and all that would change is in this step here, you would end up having this is positive and this is negative, and so you divide by a negative 2 and still get the same answer. Number 3 here, between my two variables, I'm going to move 3k. Now there's actually two reasons I'm moving 3k on this one. One, it's smaller like we talked about, but two, if I move it this way, I already have my variables on one side, numbers on the other. That's already done because I don't have any numbers over here. So even if this were to be bigger, like let's say this was 10k, I would still prefer to move the 10k in this problem because it moves it away from the side that has all the numbers. So there's only variables on one side, only numbers on the other. So my preference there for keeping it positive would be trumped, by trying to make sure that I have my variables and numbers separate as quick as possible. So here I'm going to go ahead and subtract 3k though as the problem stands, and get 4k equals negative 36. Divided by 4, and k equals negative 9. Moving on to number 4. Of these two variables, one on each side, my smaller one is negative 2u. I don't have to worry about, like I did on the last problem where only one side has a number. So we're going to add 2u to both sides, moving my smaller one. You could subtract 9u from both sides as well, of course. 12 equals 11u plus 45. Now if I subtract 45 from both sides, I get negative 33 equals 11u. Dividing by 11, we get u to equal negative 3, and that's our answer. Number 5 here, we have m's on each side of the equation again. Out of the two, negative 6 is smaller than negative 1, so we're going to add 6m to both sides. On the right side, that zeroes out. On the left side, we get 11 plus 5m equals 51. Now that I have my variables on the left, I want my numbers to go to the opposite side here, the right. So I subtract 11, and I have 5m equals 40. Divide by 5, m equals 8. Number 6. Of these two variables, negative 10 and negative 7, my smaller one is negative 10, so I add 10k to both sides. On the left, we get 1. On the right, we get 40 plus 3k. If now I subtract 40 to move my numbers to the opposite side of the variables, I get negative 39 equals 3k. Dividing by 3, I get k to be negative 13. Now, let's move on to what happens when you have grouping symbols. So when you have grouping symbols here, we first would need to use the distributive property. So on number 7, distribute 18p minus 3 equals 11p minus 45. And now it becomes the same type of problem that we just did 6 examples of. So I move my smaller variable, 11p, by subtracting it the opposite of positive 11p. Even though this is a minus sign, the 11p is positive currently, so we need to subtract. And I get 7p minus 3 equals negative 45. That negative stays with the 45 from the previous step. Then I add 3 to both sides. 7p equals negative 42. Dividing by 7 gives me p equals negative 6. Number 8, I have multiple things to distribute. So on the left, I distribute the 2 and get 8w minus 2. On the right, I distribute negative 10 and get negative 10w plus 30 plus 4. Now this is where that combining like terms comes in, where I have 30 and 4 to combine. So I have 8w minus 2 equals negative 10w plus 34. Now you certainly could do other steps before that, combining those if you wanted to. You could move your 10w in the previous step, and you could also just move 2 over here and then combine that new number in 4, that new number in 30, depending on how you combine them. But I just find it easiest and simplest to combine like terms before moving variables and numbers from one side to the other. I find it helps us to make less mistakes that way. So now my smaller variable is negative 10w, so I'm going to add 10w to both sides. And that gives me 18w minus 2 equals 38. Sorry, try that again. 34. Adding 2 to both sides, I get 18w equals 36. And now if I divide both sides by 18, w equals 2. Number 9 here, having to distribute this 9, we get 9m minus 27 plus 3m equals 7m plus 43. So I do have like terms to combine, so I combine those m's on the left-hand side, and I get 12m minus 27 equals 7m plus 43. Now that I've combined everything, I have 4 terms left, so I have to move my variables to one side. So I'm going to subtract 7m, which is a smaller one, from both sides, and get 5m minus 27 equals 43. adding 27 to both sides gives us 5m equals 70. Now if I divide by 5, m equals 14. Number 10 here, I have to distribute just this negative 7, so I have to make sure that it's not just a 7, but a negative 7. And so I get negative 7 times 2a is negative 14a. Negative 7 times 3 is negative 21, equals 23 minus 2a. On the left-hand side, I combine the constants, and I get negative 14a minus 37 equals 23 minus 2a. If I were to rearrange those two, that's perfectly fine, as long as I keep them both negative. Now my smaller variable is the one with negative 14, that is smaller than negative 2, so I'm going to add 14a to both sides. And I get negative 37 equals 23 plus 12a. There, I can subtract 23 from both sides to get my constants to the opposite side of the variables, and I get negative 60 equals 12a. Now I can divide by 12, and I get a to equal negative 5. Number 11 here, I have to distribute this negative, it's just a sign, so you can think of it as a negative 1 and multiply it, or you can think of it as just changing the signs, which is what I'm going to do that are inside the parentheses. And then on the other side, I have to distribute this negative 2 as well. So I'm just going to rewrite what I have here on the left. 5x minus x plus 18 equals 6, negative 2 times x, negative 2x, negative 2 times 15, negative 30. Combining like terms, on the left I combine those x's to get 4x plus 18. On the right I combine constants to get negative 2x minus 24. Now my smaller variable is the negative 2x, so I will add 2x to both sides. I get 6x plus 18 equals negative 24. Now if I subtract 18 from both sides, I get 6x equals negative 42. Dividing by 6 on both sides, I get x equals negative 7. Number 12 here, I have multiple things to distribute again. 8 times y is 8y, 8 times 4 is 32, and on the same side of the equal sign, I have to distribute this negative 2, so I have to make sure it is negative. Negative 2 times y is negative 2y, negative 2 times negative 1 is positive 2, and that equals 70 minus 3y. On the left-hand side, combining like terms, 8y and negative 2y give us 6y, and 32 plus 2 give us 34. And that equals 70 minus 3y. My smaller of my variables is the minus 3y, so I add 3y to both sides. And I get 9y plus 34 equals 70. Subtracting 34, I get 9y equals 36. Dividing by 9 on both sides, I get y to equal 4. And that wraps up section 2.4, variables on both sides.